My name is Michael Ruffin, and this is my Project 3.
So the objective of this project is to find the displacement vector of the end effector from its initial position to its endpoint based on the rotation of the two joints along the manipulator. And the three dots you see here on the board are the three endpoints of the end effector based on the three angles that we're given to input into the manipulator's programming.
So this is the PSOC code that was used for this project. It's pretty much the same code from the previous project where we could input whatever angle we wanted to and just observe the distance that it traveled and observed how far it extended based on those angles. But for this project, we're given three angles to input, and we have to find the displacement and then calculate it based on those given angles. And this is the Python code for this project, which was used to calculate the final displacement vector of the end effector using the same angles we input into PSOC. So what this does is, using those angles that we input, it creates a matrix for each joint along the manipulator, and it takes the product of both matrices and calculates the final displacement vector of the end effector. So this is a video of my manipulator running that PSOC code to extend both joints out to 45 degrees. I did use an external power supply in order to do this. And as you can see, I went through already and marked each point that it stops at, but you can still see where the end effector stops. So for the 45-degree angle, the end effector stops at this far right point, which is slightly different from the one demonstrated in the video just because my joints didn't fully extend to the 45 degrees. Even though they didn't extend all the way out, they still kind of follow the same pattern, the overall pattern that was shown in the video. However, the specific location that it stops at is a little different. So the matrix for this 45-degree angle code is the one at the top with all the long numbers. And as far as the displacement vector of that matrix for the X and Y planes should be 4.24 by 9.74. But like I said, mine did come up a little different. So mine was approximately 6.90 by 8.20. And here is the video of me running the 60-degree code. So for the 60-degree angle code run, the end effector stopped at this middle point. The matrix for that 60-degree code is the one in the middle. And as far as the displacement vector of that matrix on the X and Y planes, it should be 0.25 by 9.95, whereas mine came up to about 3.75 by 9.75, which is actually closer to the displacement vector of the 45-degree angle code. And here's the video of my manipulator running the 75-degree angle code. So with both joints rotating 75 degrees, the end effector stops at this far left point, which is very close to the y-axis. The matrix for that 75-degree angle is at the very bottom, and the displacement on the X and Y planes come up to negative 3.21 by 8.54, where mine came up to about 0.20 by 9.60, which is very close to the displacement of the 60-degree angle that was demonstrated in the video. So it seems that the displacement I get for each angle comes up about a vector short, because my 60-degree displacement matched the 45-degree displacement, and then my 75-degree displacement matched the 60-degree displacement. So even though it's coming up a little short each time, it does follow the same path along those two planes. And that is my Project 3.